So in this lesson, as we approach more towards the end of our review for pre-calc, this one here is converting rectangular equations to polar forms. So we have x squared plus y squared is equal to 36. Now this is in the rectangular form, right? If you think about it, it's really the equation of a circle, right? If you recall, the equation of a circle is x minus h squared, right, plus y minus k squared is equal to r squared, right? Where h comma k is the center of the circle, right? Really here we would say that the center is 0 comma 0. That's where we're getting x squared plus y squared and has a radius of 6, right? So we know that, but we want to convert this into polar form. Well, we know x squared plus y squared is equal to r squared, so we can say that r squared is equal to 36, right? And so r is equal to positive 6 and r is equal to negative 6. So our really the two equations that we have, or the two polar forms that we have that represent this rectangular equation above, x squared plus y squared is equal to 36, or r is equal to 6, and r is equal to negative 6. So that was question number 93, right? And now we have question number 94. So question number 94 here states that 3x minus y plus 2 is equal to 0. And we want to convert this into polar form. Well, you know what x is. You know x is equal to r times cosine theta. So the first thing is you want to just put that in, right? So you know it's 3 times r cosine theta. And you know y is r times sine theta. So that's minus r times sine theta plus 2 is equal to 0. The thing here is you always want to make sure that you have 0 on the right hand side of your equation. And so that's an important concept here. And so we have 3 times r cosine theta minus r sine theta plus 2. So we're really just putting those values in. And the thing here is that whenever we want to convert from rectangular to polar form, you want to make sure that you're left with r and theta, right? No x's or y's, because x's and y's are only exist when we're talking about a rectangular system. R and theta should be the only things that are left when we are converting into polar form. So right now we have this, and really it makes sense because we have radius, we have theta, we don't have any x's and y's, so we should be done. But it's always good to factor, so we're left with r times 3 cosine theta minus sine theta plus 2 is equal to 0. So this is our final answer here for question number 94. So although it's not a circle, that's just the equation we have after converting this rectangular equation above into the polar form. So that's question number 94. So now I have question number 95. Right, this is x squared plus y squared minus 6x is equal to 0, right? So let's just think about this. So we know that x squared plus y squared is equal to r squared. So we know that we can write this as r squared minus 6x. Well, x is just r cosine theta. So we can say minus 6 times r cosine theta. This should be equal to 0. Well, we can then take the r, factor the r out. So we have r times, within the parentheses, r minus 6 cosine theta is equal to 0. Well, you can divide both sides by r, and you're left with r. Well, you're left with, so you have, well, so if you think about this now, right, you can divide both sides by r, as I said, so the r goes away, so you're left with r minus 6 cosine theta is equal to 0, right? And if you think about this, you can write this in terms of r. That's a good thing. So you can say that r is equal to 6 cosine theta. R is equal to 6 cosine theta. So that's the value of r here, and so we have converted our rectangular equation here into the polar form, right? And obviously I said you can have 0 here, but if you can write theta and r and connect those two like this, r is equal to 6 times cosine theta, that's always the preferred method, right? So we have simplified as much as we possibly could have. And so really when we think about this, whenever you have r is equal to some constant times cosine of theta, or some constant times by sine of theta, that polar form is referring to the shape or the conic of a circle, right? It's that conic. If you recall, the conics include circles, ellipses, hyperbolas, and then parabolas, right? So this specific form here, r is equal to some constant which you could say is a times by sine theta or cosine theta, is referring to that conic of a circle, right? It's referring to the shape of a circle, which means that if this is a circle, right, if this form here is a circle, well then this over here should also be a circle, and it is. If you can't see it, you will in just a second, because you can use the method of completing the square to really see that this is a circle. So we know that x squared minus 6x, right? Well, this is b, so we can divide that by 2, that gives us negative 3. Square that, that's plus 9. So we have x squared minus 6x plus, well, we are adding 9, right? Then we have plus y squared, right? And so all we have done to this side of the equation is we added 9. We have to do the same to the other sides. We are left with 9 here, right? And so then we can write x squared minus 6x plus 9 as x minus 3 squared plus y squared is equal to 9. Now if you look at this equation, obviously this is in rectangular form. The center of this circle is 3, 0, and its radius, right, is radius. So as you saw here, I said this is equal to 9. So the radius here would obviously be equal to 3, right? The square root of 9. So this is obviously a circle, right? If you don't see it, you can complete the square, and then you will see that this does go into that form of x minus 8 squared plus y minus k squared is equal to r squared. So, but our final answer here is r is equal to 6 times cosine theta. So thanks for watching.